Hey, I'm Dana with Paperless Parts, and we are a quoting and estimating platform for custom part manufacturers. And today I'm going to be talking about how we can help automate building your router for machined parts. So if you work at a shop and you make parts and you think your quoting process could be more effective, then this video is for you. As a quick intro to Paperless Parts, we are a holistic workflow automation solution for all things quoting and estimating. So from RFQ received to PO1, we are involved in streamlining workflows and automating decisions along the way to help your shop quote faster and more accurately. So Paperless Parts is what I like to call an 80-20 platform, and that we focus on automating the first 80% of the quoting process while supporting you and allowing you to spend your time focusing on the remaining 20% of the process. The way I like to think about this is when breaking down an RFQ for a machine part, you've got, upwards of like 100 questions to answer. There are a lot of basic questions like what is the material, who is the customer. There are some more complicated questions like how complex is this part? What machine should I run the part on? Can I hit all the features? And then there are the most complex questions like, am I properly accounting for critical tolerances, or what is my cycle time on the mill? So paperless parts can help automate with a lot of the questions in that easy and medium category. Again, automating that 80%, let you focus on the 20%. And this is really going to be able to help your shop with this 80-20 automation because it's going to be able to empower the broader team. You're going to be able to share quote tasks across multiple people, allow junior staff to focus on the simpler parts and the senior estimators to focus on the more complex tasks. You'll be able to ramp up those junior estimators faster, ultimately future-proofing the quoting function at your business. And you'll also get just general process improvement. You'll be able to prioritize and allocate resources to the right tasks and opportunities. You'll be able to start to parallelize formerly linear workflows. And there's just going to be a lot less data entry. So today, I'm going to show you how to automate building your router for machine parts using an object called a process within Paperless Parts. So specifically, we're going to talk about using templates to quickly set up the most common routers that your shop encounters. And we're going to talk about how you can use the Paperless Parts milling interrogation to determine things like which machine you should run a part on and determine if you need any outside special processing steps like gun drilling. So as a quick disclaimer, in this walkthrough, you're going to see me make some edits to my paperless configuration. Please understand that we will do all of this configuration for you during onboarding, and post onboarding, we can offer resources to teach you how to do this yourself, or you can just work with our team directly if you want to make edits. So without further ado, let's dive into it. So if we set the stage a bit, when you're quoting, you're essentially doing a rough simulation of how the part is going to flow through your shop, building out a router, including the raw materials that you're going to need and the operation steps to consume those raw materials. And then once you have your router, you can then estimate the cost associated with each of those raw materials and operation steps using costing formulas. And today we are going to talk about the engine that generates that router in Paperless Parts, which is called the process. So let's switch over to the quotes page and let's get up a list of processes. So I'm going to focus in right here. I'm going to click change process. So in Paperless Parts, a process is essentially a templated list of material requirements and work centers. So I've got a lot in this list, right? I've got an assembly process, I've got a milling process, I got a turning process, I've got some sheet metal processes. These are essentially just mapping to the different types, the common types of parts that flow through your shops with a common route. So the coolest thing about processes is they can actually reach into the geometry of the part and use the features and properties that we extract from the model. So things like the bounding box or any of these features we detect or manufacturability warnings we detect on the left, you can use all that information and essentially ask questions of the geometry. Questions like, what type of manufacturing process should I use? What work centers can you fit on? Do you have any problematic features that I cannot manufacture? And that's exactly what processes can do. So to start this demo, what I'm going to do is I'm going to assign my custom milling demo process, which I built purpose for this, and I'm going to assign a 6061 material. So when I hit update here, what's going to happen is it's going to drop in a list of routing steps and material requirements, right? So we see we're pulling in an aluminum bar pricing. We've got an admin step, a programming step, a CNC mill, a QA, and then a shipping prep step. So this is a very typical looking router, and I want to sort of pull back the curtain and show you guys how this actually works. So if we look at this part, we can see we pulled in that 3-axis process. But based on the number of machine directions that the system is recommending, we've got a high number of these. It's going to take a lot of setups to run this on a 3-axis. So I think this is actually a better fit for my 5-axis machine. So let's figure out how to have the system automatically look into these machine direction counts to make that decision automatically. So again, I've got this custom milling demo process assigned. So I'm going to go over to my processes page and I'm going to search for that process. Here we go. And this is what a process looks like in Paperless Parts. We can see I've got my allowable list of operations, and then we actually have a formula that's responsible for generating those material requirements and operations. So if I open this up, you can see we've got some really simple code here, right? We're generating all of the operations, right? The material bar processing, the critical information, the admin step, the programming, the CNC mill, the QA, and the shipping prep. Those correspond exactly to what you're seeing over here, right? So let's say we wanted to automatically respond to the number of setups that the 3-axis interrogation is detecting. So if we wanted to do that, instead of just generating this 3-axis mill operation every time, what we can do is we can actually look at the interrogation information and say, if the setup count is less than or equal to 3, that means it's a decent fit for the 3-axis. Otherwise, we're going to throw it on the 5-axis. So I'm just going to save these changes, pop back over to my quote, and if I do regenerate operations, we'll see that we'll move from the 3-axis here to now a 5-axis operation with 2 setups instead of the 6 setups that were getting called out before. So this is just a very simple example as to how you can tell the system to look into the geometry to automate some of those decisions on building your router. So let's think of another example here. So let's look back at our part in the viewer here. We see, so we're already handling that machine direction case. Let's look at some of the features on the part. I want to make sure I can hit all of the features on this part in-house. So I want to focus in on this deep hole here. So we can see this is a really deep through hole. And if we expand the properties here, we can see it's actually got a depth to tool diameter ratio of 11.82. So let's say I know in my shop that the maximum depth to tool diameter ratio I can drill is 10. And above that, I'm going to need to send this outside my shop to get it gun drilled. So let's see how we can execute that logic automatically in the custom process. So luckily, I've already pre-configured this. So what we can see here is we're looking at all of the manufacturability feedback. We're filtering for deep holes, and we're looking for depth to tool diameter ratios of greater than 10. So if I just check save here, shoot back over to my quote, and then click regenerate operations, we should see that gun drilling operation right here get pulled in because it's looking at the geometry of the part, looking at those deep holes that are called out by the interrogation. So again, just another example of how Paperless Parts can help automate some of those decisions that might come simple to maybe a more experienced estimator, but can be a huge game changer for driving consistency and ramping up more junior folks on the team a lot faster. So to recap, Paperless Parts can help you answer a lot of questions about machine parts really quickly when quoting, leaving only the most complex questions and decisions to you to answer. So if you think that this sort of thing can help your shop quote more effectively, we'd love to show you more. If you're interested in learning more, please check us out at paperlessparts.com. I've been Dana with Paperless Parts, and we hope to see you soon.